Let's talk about the Leecode problem 32A1. First part is description. You are given an array of integer starts and a integer d that represent n internals. Every internal is starts I plus d. You can choose one integer from every internal. As a result, you can get an array of integers. The score after that, you can get is the minimum of difference of any two integers of your selected. This is the description of this problem. The next part is the solution. For this kind of problem, the common solution is use binary search. Let's talk about the binary search. You have a possible smallest answer L and the possible biggest answer R. Every time you can check the mid plus L plus R divided by 2. You can check the middle of L and R if they can meet the demand of the limitation. If the answer is yes, that means mid can meet the demand of the limitation, so the correct answer is this internal. The left of the internal is mid, right is R. In contrast, if the answer is no, we can know the correct answer should be the internal L, mid minus 1. So this is the binary search. For a specific problem, the most thing we need to do is how to define the check function. To define if the mid can meet the demand of the problem or limitation. For this problem, what we can do is to check the mid can meet the limitation. What we need to do, what we have is n internals. Everyone is start 0 plus d. Next is start 1 plus d. So we can choose every integer from this internal. That means S1, S1, S0, S1. We can make this split to several situations. First of all, first situation. We can choose the one integer from this. I mean, we can make the S0 as the current point. For the mid, we have chosen if the S0 plus mid. In this, that means this is the mid. That means S0 plus mid is more than the next point, the end of next integer. That means start. Next, next plus d. If this is more than start next plus d, that indicate the mid cannot meet the demand of the limitation, because you must choose one integer from this internal. So S0 and S1, the difference between S0 and S1 is much smaller than the mid. As a result, we will return false at the result of check function. This is the first situation, right? Let's talk about the second situation. You have many internals. This is your current, and it means the S0 in the last situation. If the S0 plus mid in the middle, within the internal of the next internal, so we can choose the next that means S1. We can choose the next selected integer as the SO plus mid. This is the next integer we should choose, and this can meet the demand of limitation. We should check the next time as 0, and we should do the next check. This is the situation 2. Let's talk about the next situation. If the current S0, that means the current selected integer, if it plus mid in this point, in this position, this is mid, we must choose an integer in the next internal. So the star of next interval should be the integer we should select. That means select next. That means start plus 1. So we shouldn't make this. We cannot select this integer. So this also can meet the demand, and we should check the next internal and get the final result of check function. Actually, this is the most common situation, but we also have next situation. That means the two internal in this situation. If this is S0, so when we select the next point, it must be in this internal. This is common. This is like the situation 2, right? If the choice in this position is like the situation 3, so it is the part of the situation 2 and 3. This is all the answer. This is all the check function. This is all the check function. You can check my answer. You can check my code below this video. Next part, let's talk about the complexity. For the term complexity, for the binary search, you must do the binary search log n times for every function, for every check function. You should do the check function. That means one loop, you can do this kind of thing, one loop. So the time complexity is O(n). So the final time complexity is O(n) multiply log n. For space complexity, we don't need extra space, so the answer is O(n). So this is all the solutions. Thanks for your watching.